Bismillah ar-Rahman ar-Rahim. Dear students, Assalamu alaikum to all of you. I hope that you all are fine, happy and fresh. This is your science teacher, Muhammad Mashood Khan, and today we are going to discuss the question answers of chapter number 4, that is electrical circuits, page number 54. So the question number 1 is, draw symbols for a bulb, a motor, a buzzer and a bell. So you have been asked to draw the symbols of all these electrical appliances. So you can see this is the symbol for bulb. You can see a circle having a cross in it. Then the next one is the buzzer. You can see the symbol for it. Then the motor, it's just like a simple circle. Inside we can write M and the lines on the both sides. Then we have a battery. Battery is not asked in the question, but you can see the symbol for the battery. Two vertical lines. One is the greater, one is a bit larger than the other one. So these two vertical lines show the symbol of battery. For wire you have a straight line, and for open switch you have two lines between them which we have a space, and which there is a line which is connecting them. Sometime when the switch is closed, this line or this wire is touched with this terminal, so the cap is removed and it is connected with each other. These two wires are connected with each other, and the result is that it allows the current to flow. Then you can see the symbol for the electric bell. This is the symbol of electric bell. Yes, electric bell, and these are the two batteries which are in the circuit. So you have to ignore the symbol of the batteries, but you have to notice the symbol for the electric bell. So this is it. You can draw it by yourself just to memorize and keep in your mind. The next question is, list the energy changes that takes place in the following electrical components: a buzzer, a lamp, a motor and a battery. So you have been asked that, in this question you have been asked that you have to tell that what are the energy changes taking in the following electrical components. Like you have to tell which type of energy is converted into which type. So basically the question is this. So the answer is A. Electrical energy is turned into sound energy in a buzzer. So buzzer means it buzzes, you hear the sound. So how the buzzer work? It needs electricity. So basically what is happening, that the electrical energy is converted to sound energy. Then we have electrical energy is turned into heat and light energy. So this happens in lamp. So in the lamp, when you lit up a lamp, so you will notice that the electrical energy is converting into heat and light energy. How you will get to know that the electrical energy is converted into heat and light? Because to lit the lamp you need electrical energy. So it is the input, basically it is the energy which you are giving to the lamp to get lit. Then the second part is that in result, consuming the electrical energy, bulb is giving you a light, and plus after some time when you will touch the lamp it will be a bit hotter. Don't touch it because it will be hot, but you can initially, as you just lit up the lamp, you can just touch and you can check it out, but it's better not to touch because it is obvious that it get heated. So this is the answer, that in lamp electrical energy is turned into heat and light. Then we have a motor. In motor, electrical energy is changed into mechanical or movement energy. Yes, for a motor, just like you have a grinder in your home, so what you need to run it, you need electrical energy, and in result what happens, that the machine runs. It works mechanically, and mechanically means that it moves. So basically electrical energy is converted to movement energy or mechanical energy. And the last one is a battery. So in a battery, chemical energy is turned into electrical energy. If you have dry cells at your home, you can experience it, you can check it out, that inside that cell you will be having some chemicals. And what this chemical do, that it provides you the electrical energy. Because when on wall clock, you see, you put some these drive cells in the wall clock, in a result what happens, that wall clock runs and it shows you the time. So basically what is happening, that the chemical energy is changed to electrical energy, by which the electric wall clock is running. I hope that you have understood. The next question is, why is important to keep electrical components clean? This is a very important question. That why is it important to keep electrical components clean? Electrical components must be kept clean so that they do not corrode, they are reliable and last longer. Yes, if your electrical appliances are not clean, so what will happen, that it will get rusty. It will get rusty and they will not work properly. In Urdu we call rust as zang, जिसको उर्दू में हम zang कहते हैं. So if this rust will come to the electrical appliance, what will happen, that it will block or it will resist the electricity. It is basically the impurity which will resist the electricity to run. This is why sometimes even in cars the electric plug get rusty and mechanic take it out and it just make it neat clean. It rubs it with some sandpaper or something like this, by which it makes it clean, and then it works properly and the car you can drive easily then. Otherwise it will be creating problems. Why? Because of rust the electricity will not flow properly and the electrical appliance will not work properly also. The next question is, what is the insulator between the components of a bell push switch when it is off? So the gap between the contacts act as an insulator. In the gap between contacts there is air which acts as an insulator. So the question was asked that what is the insulator between the components of a bell push switch when it is off. So basically they are asking that when the bell switch is off, what is the insulator between the two contacts? So basically between the two contacts there is air, there is a gap. So this gap is filled with air, and air is a good insulator, because if air was not a good insulator, then it could have been a great problems for the humans, because then electricity could have traveled in the air also, which could have caused lot of damage to the humans. So between the two contacts there is air, and air is a good insulator, so current cannot pass through it. There is, before going to the reed switch, I will just show you the working of a switch. Basically I am recalling it, that you can see the working of a switch, that there is a bulb, there is a battery, there is a switch, and you can see that the switch is opening like this. So when this switch is open, which means that there is no contact between the two terminals, and the circuit is broken out and the electricity is not passing through. I have already explained in the previous video, so if you want to check out in the details, you can check the previous video also. Now we are going to check out that how a reed switch works. A reed switch is operated by a magnet. When a magnet is held close to the switch, the contacts close and the switch is on. The switch is off when the magnet is removed. So basically reed switch is the one which works with the magnet. In the next figure you can see the animation of it. Now you can see here, as the magnet is passing through the reed switch, it pulls the switch down and the circuit completes and the electric current flows, and you can see the bulb is glowing. When the magnet goes away, the switch goes back to its previous position, which is the open position, which means the circuit is not completed and the circuit is incomplete, so it will not allow the electricity to flow, and you can see the bulb is turned off. So this is the working of a reed switch. I hope that you have understood this all, and if there will be any question, definitely you will ask me in the class. Thank you and have a very nice day.